Students, let us continue the Venturi meter problem. So from last class, last video, we seen horizontal Venturi meter. So in this portion, we will discuss inclined Venturi meter or vertical Venturi meter. Okay, there are two categories. Suppose a Venturi meter is placed horizontal manner, means it is called horizontal manometer, or somewhat inclined or vertical means it is called inclined Venturi meter. Okay, now I will read the problem. Yeah, 30 centimeter into 15 centimeter Venturi meter is inserted in a vertical pipe carrying water flowing in the upward direction. A differential mercury manometer connected to the inlet and the throat gives a reading of 20 centimeter. Find the discharge in the pipe. Take CD. What do you mean by CD? So CD is nothing but coefficient of discharge is 0.98. Okay, 0.98. So please read the question once again. So the Venturi meter size is 30 centimeter into 15 centimeter. Okay, is inserted in a vertical pipe. So now the pipe is in vertical portion, carrying water. The fluid is water, flowing in the upward direction. So previous section we seen water is flowing in the horizontal direction. Now water is flowing in upward direction. Okay, so the differential mercury manometer is connected to the inlet and the throat. Okay, this is a reading. That means the difference in the mercury level is 20 centimeter. Find the discharge. So now write the given data. D1 is 30 centimeter corresponding. So I kept all the values in terms of centimeter. Otherwise you can keep in meters. Okay. So D1 30 centimeter. So corresponding area of the pipe is pi by 4 into D square, and D2 is 15 centimeter. Here they given size of the Venturi meter. Okay, the size indicates first dimension indicates the diameter of the pipe, and the second dimension indicates the diameter of the throat of the Venturi meter. Okay, so D2 15 centimeter and the corresponding E2. Next, H pressure head, which is equal to X into SH divided by S0 minus 1. Okay, so X is the differential manometer reading. It is 20 centimeter. It is also given in the question. So 20 into specific gravity of the heavy liquid. So here mercury is there. Okay, in the manometer mercury. So specific gravity of the mercury, what it is 13.6, and divided by S0 is the specific gravity of the lighter liquid. It is water. Okay, the pipe carries water only. So specific gravity is 1. Okay, so finally we got the answer 12.6, and 20 into 12.6 we got 252 centimeter of water. This is the pressure head. So CD is 0.98. So we know that the discharge formula, actual discharge formula. Okay, so CD into theoretical discharge. So this is coefficient of discharge, and this portion is the theoretical discharge. Okay, so now Q is equal to CD into A1 A2 divided by root of A1 square minus A2 square into root 2 GH. Okay, so CD is 0.98. It also given in the question, into A1. A1 is here and A2 is here and H is here. So substitute all the values in the equation. So finally we got how much? So 1,25,756 centimeter cube per second. So if you convert it into liters per second, means 125.756 liters per second. Okay, so this is the important problem in the inclined Venturi meter. Okay, so mostly in the examination they will not give diagrams, so they will give only sentence format only. Okay, so based on the sentence format, you must draw the diagram and understand the question. You must draw the diagram. If you draw the diagram correctly, means the problem is easy. So now let us move to the next problem. So yeah, 20 centimeter into 10 centimeter Venturi meter is inserted in a vertical pipe carrying oil of specific gravity 0.8. So now here there is no water is flowing, oil is flowing. Okay, so they given this specific gravity, it is 0.8 in the upward direction. The flow of oil is in upward direction. So same like previous problem. So the difference of levels between the throat and the inlet section is 50 centimeter. Okay, so here keep it in your mind. So this is the Venturi meter held in vertical motion. Okay, so this is your inlet pipe. It is like this. Okay, so what they given, the difference are levels between the throat and the inlet section. So difference in level throat and inlet section is 50 centimeter. So the meaning of that one is, okay, this is the diagram. Okay, the difference of level between the throat and the inlet section is 50 centimeter. Okay, the oil of mercury differential manometer gives a reading of 30 centimeter. So the differential manometer gives the reading of 30 centimeter of mercury. Find the discharge of oil, neglect, losses. So what are the data given? D1 is given 20 centimeter and corresponding A1 is 5/4 into 20 square, and D2 is given 10 centimeter and the corresponding area is A2. So it is 5/4 into 10 square. Okay, specific gravity of oil, this also given in the question. It is 0.8 and specific gravity of mercury 13.6. We know it is a standard one. Differential manometer reading x equal to 30 centimeter. Okay, now H, what is the formula? See, these are all unnecessary formulas. You don't consider this one. So we know the standard formula. H is equal to S into SH, either SH or SG. So keep it as SH. Okay, SH divided by S naught minus 1. So what is X? X value given in the question 30 centimeter. Okay, so this is your X 30 centimeter and SH 13.6 and S naught 0.8 minus 1. So we get an answer 480 centimeter of oil. 480 centimeter of oil. So this is the difference in the pressure head. Okay, gives in the manometer. So next CD value. So you can see here CD value is not given in the question. Okay, you can see in the question. So you can see here CD value is not given. Okay, so if you CD value is not given means you have to assume. You have to assume that CD value. So here I assume the CD value is 1. Okay, CD value is 1. You can assume between 0.95 to 1 because the Venturi meter having high coefficient of discharge compared to Orificemeter. Okay, we will see Orificemeter later. So the CD value for the corresponding Venturi meter I assume is 1. You can assume 0.98 or 0.99 also, whatever. Okay, because in the question CD value is not given. If they given means you have to substitute that corresponding value only. Okay, so next discharge. Discharge Q is equal to, you know the formula, CD into A1 A2 divided by root of A1 square minus A2 square into root 2 GH. So substitute all the values. So CD value is 1. So here this is the CD value 1 and A1 A2 we already found. And H value is 480 centimeter. So here you can see G value I put 981. Okay, so G value in terms of if meter means it is 9.81. Here I substituted all the values in terms of centimeter, so it is 981. So keep it in your mind. So it is based on the units you taken. If you do your problem in terms of centimeter means you put 981. Okay, so in case of you selected meter means you have to put 9.81. Okay, now substitute all the values. Finally you got 78,725.75 centimeter cube per second. So in terms of liters means it is 78.725 liters per second. Okay, So this is the problems in the inclined manometer. Okay, nothing changed. Problem is that formulas are same. If any data not given in the question means you have to assume. Okay. So next problem. So this is one of the important problem. So in a 100 mm diameter horizontal pipe, 100 mm diameter horizontal pipe, a Venturi meter of 0.5 contraction ratio. What is meant by contraction ratio? We already know that the diameter of throat is half of the nearly, okay, half of the diameter of the inlet pipe. So here the diameter is given 100 mm. So 0.5 contraction means the diameter of the throat is 100 into 0.5. It is nothing but 50 mm. So they given indirectly. Okay. So 0.5 contraction ratio has been fixed. The head of water on the meter when there is no flow is 3 meter. Okay, the head of water on the pressure when there is no flow, if the that means the fluid is in static condition. So under that static condition, that means at rest condition, the head of water is 3 meter. Find the rate of flow for which the throat pressure will be 2 meter of water absolute. Okay, so here also they ask rate of flow. What is the other name of rate of flow? It is discharge. Okay, the coefficient of discharge is 0.97. Take atmospheric pressure head is 10.3 meter of water. Okay, so here the coefficient of discharge also given. So let us see the problem. So how to find the discharge? So D1 is given 10 centimeter. So corresponding area 5 by 4 into D1 square. So we got 78.54 centimeter square. Okay, substitute D1 as 10 centimeter. Next, diameter of throat D2. Okay, D2 is 0.5 into D1. So 0.5 into 10 is equal to 5 centimeter. Next, area. So area, corresponding area A2 pi by 4 into pi square. Okay. Head of water for no flow. That means pressure head is P1 by rho G is given by 3 meter. P1 by rho G is given by 3 meter. It is the gauge pressure. So what is the absolute pressure means 3 plus 10.3. Okay. So gauge pressure plus atmospheric pressure head. Gauge pressure plus atmospheric pressure head. So 3 plus 10.3. It is 13.3 meter absolute. Okay. So but here at the throat they directly given the absolute pressure also. Okay, the throat pressure head is P2 by rho G is 2 meter of water absolute. But here they didn't give absolute pressure. They given only a gauge pressure. So we have to find absolute pressure. Okay, so for that purpose only they given the atmospheric pressure head 10.3. So we have to add the gauge pressure plus atmospheric pressure. We can easily get the absolute pressure. Okay, so don't substitute the gauge pressure. You must convert it into absolute pressure. Okay, so for that we are adding the atmospheric pressure. So sometimes in the question this atmospheric pressure also they will not give. So 10.3 meter is the standard one. It is the standard one. Okay. So next, difference of pressure head. So H is equal to, here the mercury manometer readings are not given. So if the mercury manometer reading is given means we have to use previous case formula. That means H is equal to X into SH divided by S naught minus 1. So here mercury manometer reading is not given. For that purpose they given pressure. Okay, that means that gauge pressure and absolute throat pressure. So using this formula, if pressure rate is given means we have to use this formula. That means P1 by rho G minus P2 by rho G for calculating the difference of pressure head. So we got 11.3 meter. Okay, if you convert it into centimeter means 1130. Okay. okay, centimeter. That means 11.3 into 100. So now rate of flow. So once you found H, okay, once you found H means substitute in this formula, we can easily get the rate of flow. So CD into A1, A2 divided by root of A1 square minus A2 square into root 2 GH. So substitute CD value also given in the question. What is that value? It is 0.97. So substitute all the values in this equation. H value also given. It is 1130 centimeter. Substitute all the values, we can get the answer. So 29,306.8 centimeter cube per second. If you convert it into liters per second means it is 29.306 liters per second. Okay. So this is your Venturi meter problems. So up to this Venturi meter problems are over. So next we will move to the Orifice meter. So Orifice meter and Venturi meter nearly both are same. Even formula also same. So only the difference is, so if you take Venturi meter, there will be an inlet throat, a convergent throat, a divergent part. There are three parts. But in case of Orifice meter, only one part. That means that orifice plate. Okay. So you know that orifice. What is the orifice? Simply, generally, orifice is nothing but a hole made in a plate, a circular plate. So always orifice means a circular section. Suppose this is a circular plate is there, a metal plate is there. I want to make a small hole in that plate. So this small hole is nothing but orifice. This small hole is nothing but orifice. Okay. So what in by orifice meter means? So orifice meter also a discharge measuring device. Okay, discharge measuring device. Even formula also same compared to Venturi meter. Formula also same. So when an orifice plate is placed in a pipe, so suppose this is a pipe diameter and this is a orifice plate. Okay, so compared to diameter of the pipe, orifice plate diameter is more. Okay, and so in that orifice plate there will be a small hole is provided. So water is flowing in this portion. That means the larger diameter pipe. Okay, while entering in the orifice plate, it's flow in this small diameter pipe. Okay, so that is the flow of water taken place in the orifice plate. So when an orifice plate is placed in a pipe carrying the fluid, those rate of flow is to be measured. The orifice plate causes a pressure drop. So initially water is flowing in a larger diameter pipe. So while entering in the orifice plate, the flow of water taking place in that orifice diameter is very small. Okay, nearly half of the diameter of the inlet pipe. Okay, so what happened? There will be a pressure drop is occur. Okay, which varies with the flow rate. This pressure drop is measured using a differential pressure sensor or a differential mercury manometer. And when calibrated, this pressure drop becomes a measure the rate of flow. So what are the advantages? It is a cheaper device as compared to Venturi meter. So for making Venturi meter, we need a convergent cone, a divergent throat. But here there is no convergent throat or divergent. We need only a plate with a central orifice, central hole. This also work on the same principle as that of Venturi meter. It consists of a flat circular plate which has a circular hole at center, from the center. Okay, in concentric with the pipe. What do you mean by concentric? That means the diameter of the orifice plate, and diameter of the orifice center is same. That this is the meaning of concentric. Okay, so this is called orifice. The diameter of the orifice is generally 0.5 times the diameter of the pipe. As I already told, if suppose the diameter of the inlet pipe is 100 mm, means the diameter of the orifice is 50 mm. So also depends on the application, it will vary 0.4 to 0.8 times of the diameter of the. Generally it is 0.5 times only. So it is based on the industrial application, it may vary 0.4 to 0.8. Okay. Now you can see this is the cross section of the orifice meter. This is the cross section of the orifice meter. So you can see here, this is the inlet pipe diameter. This is the inlet pipe, and this is the plate. So this yellow color is the orifice plate, and this portion is the orifice diameter. This portion is the orifice dia. Orifice dia, OD, orifice dia. Okay. So water while entering the flow, this is the flow direction. The water is entering in the orifice. So it is contracted. Okay, and again it is enlarged in this portion. So this portion is called a vena contracta. Vena contracta. Okay. So after leaving this orifice hole, the flow diameter is decreased at some portion. Okay, so this flow diameter, you can see here this line, the streamline. You can see here water is flowing in up to this. Again, due to this small diameter, it is contracted. Again, it is enlarged. Okay, so this portion is the having less diameter of flow. Okay, so that portion is called vena contracta diameter. Vena contracta diameter, and a mercury manometer is attached. Okay, before and after the orifice plate. So you can see here one limb. This is left side limb is attached in the inlet pipe. That means before the orifice plate, and another limb is attached in the after the orifice plate. Okay, so this is the picture of the cross section, picture of the orifice. Okay, so the discharge Q is equal to CD into A0 A1 root 2 GH into root of A1 square minus A0 square. Here there is no A2. Instead of A2, we put A0. A0 is nothing but diameter of, area of the orifice. Area of the orifice. A1 is same as we seen in Venturi meter, diameter of the inlet pipe. Okay, so the portion of discharge of the orifice meter is much smaller than the Venturi meter. Okay, so for we seen Venturi meter quotient of discharge is 0.98, but in case of orifice meter, it is around between the range 0.6 to 0.7. The materials used for maintaining orifice plate are stainless steel, phosphor, bronze, nickel, and monal. Monal is nothing but a nickel alloy. So these are all the materials used for making the orifice plate. Okay. So now we will move to the problem. Okay, advantage we already seen. It is very cheap and easy method to measure the rate of flow in a pipe. Okay, it occupies very less space and can be used to measure the rate of flow in large pipes. Okay, these are all the three major advantages. Sometimes they will ask in the 2 mark question. What are the advantages of orifice meter compared to Venturi meter? So let us see the first problem in orifice meter. An orifice meter with orifice diameter 10 cm is inserted in a pipe of 20 cm. So inlet diameter is 20 cm and the orifice meter diameter is 10 cm. Okay, the pressure gauges fitted upstream and downstream side of the orifice meter gives the readings of 19.62 Newton per centimeter square and 9.81 Newton per centimeter square respectively. Coefficient of discharge for the orifice meter is given as 0.6. Find the discharge of water through the pipe. So they are asking what is the discharge. Okay. So here first write the data given. So D naught is 10 centimeter and A naught pi by 4 into 10 square, and diameter of pipe D1 is 20 centimeter and A1 is equal to pi by 4 into 20 square. Next P1 pressure at induct is 19.62 and the pressure after that orifice plate is P2 by rho G. So this P1 and P2 value is given in the question. Okay. So it is 20 meter of water, here 10 meter of water. P1 by rho G is, substitute the values 19.62 into 10 to. So here I converted into Newton per meter square. So if you either you can convert or you can keep as it is 19.62 in Newton per centimeter square also. Okay. So P1 by rho G, P2 by rho G. So P1 by rho G is 20 meter of water, P2 by rho G is 10 meter of water. So H is equal to, what is the difference in the pressure where? P1 by rho G minus P2 by rho G, which is equal to 20 minus 10, 10 meter of water. So 10 meter into 100 means gives the 1000 centimeter of water. Okay, 1 meter is equal to how many centimeter? 100 centimeter. So you have to multiply 100. So 10 into 100, which is equal to 1000 centimeter of water. Okay. So keep it in your mind. If pressure only given, pressure head, not pressure, pressure head. Okay. Is given means you can directly substitute H is equal to P1 by rho G minus P2 by rho G. If pressure only given means first you have to find pressure head, P1 by rho G and P2 by rho G. Rho 1000. Okay, if the water is the liquid is water means rho is 1000 and G is 9.81. We already know. Okay, if pressure only given means you have to found the pressure head using this formula P1 by rho G, P2 by rho G. If pressure head is given means it is very easy. Just the difference, that means P1 by rho G minus P2 by rho G. So that what I am telling means first understand the question, whether in the question they given pressure or pressure head. Okay. So CD value also is given 0.6. So substitute all the values. Q is equal to CD A0 A1 divided by root of A1 square minus A0 square into root 2G H, root 2G H, which is equal to 0.6 A0 value. What is A0 value? 78.54 centimeter square and A1 314.16 centimeter square. Okay. Divided by root of A1 square minus A0 square. Okay. So substitute into root 2GH. Here I substitute in terms of centimeter. Please see this 78.54 and this 314.16 I substituted in terms of centimeter only. So again G value I have to substitute in terms of centimeter. So 981. Okay. So otherwise you can keep all the values in terms of meter means it is very easy. It is G is equal to 9.81 meter per second square. Okay. So H is 1000 centimeter. Okay. This also I substituted here. Okay. So now finally we got 68,213.28 centimeter cube per second. Okay. If you convert it into liters per second means it is 68.21 liters per second. Okay. So the only one formula, if you understand, that means if you keep it in your memory means it is very easy. That means nothing but the discharge formula. Discharge, there are two types of discharge. One is actual discharge, another one is theoretical discharge. Okay. So this Q is nothing but actual discharge, and this portion is then this is called theoretical discharge, QT. What is the coefficient of discharge formula? It is nothing but Q actual divided by Q theoretical. This you already know. CD is equal to Q actual divided by Q theoretical. So I need only Q actual. So this Q theoretical goes this side. Okay, so therefore CD into Q theoretical, which is equal to Q actual. So this is the formula I substituted here. That's all. Okay, QA. This is QA is equal to CD. This is CD into Q theoretical is A0 A1 divided by root of A1 square minus A0 square into root 2GH. This is the okay. So I hope all of you understand this problem. Next we will move to second problem. So next problem, an orifice meter with orifice diameter 15 centimeter inserted in a pipe of 30 centimeter. The pressure difference measured by a mercury oil differential manometer on the two sides of the orifice meter gives a reading of 50 centimeter of mercury. Okay, so here they given the mercury manometer reading. Find the rate of flow of oil of specific gravity 0.9 when the coefficient of discharge of the orifice meter is 0.64. Okay, so next diameter of the orifice D0 is 15 centimeter and area A0 is equal to pi by 4 into D square, and diameter of the pipe D1 is equal to 30 centimeter and area A1 is equal to pi by 4 into 30 square. So I kept in terms of centimeter only. Specific gravity of oil is 0.9. This is also given in the question. Next, reading of differential manometer X is equal to 50 centimeter of mercury. So differential head is equal to H equal to X into Hg. Hg or you keep it as SH. SH is better. Okay, heavy liquid. Okay, specific gravity of heavy liquid. SH divided by S0 minus 1, which is equal to X. X is given differential manometer reading 50 centimeter and mercury manometer. Mercury specific gravity 13.6 and oil specific gravity 0.9. This is also given in the question. Minus 1 centimeter of oil. Okay. So which gives the how much? So 705.5 centimeter of oil. So CD also given, it is 0.64. The rate of flow, that means Q is given in the question, in the equation. So CD into, so Q actual is equal to CD into Q theoretical. Okay. So substitute all the values. CD is given 0.64, A0, A1, root of A1 square minus A0 square into root 2GH. Okay. So finally, substitute H is equal to 705.5. So substitute all the values. We got 137.414 liters per second. Okay. So what is the main thing in this problem is, you can observe that here they given mercury manometer reading, differential manometer reading. It is 50 centimeter. Okay, differential manometer, difference in level of the mercury is 50 centimeter. So that value is nothing but X value. So using this differential head formula, we can easily find the H value. Okay, so if pressure is given, means we have to use previous case problem, that formula. Okay, so for that only again I'm repeating. First understand the question. So what they given in the question, either pressure head pressure or difference in mercury level. Okay, so according to that question, the formula also will change. Okay, so after this Venturi Orifice meter is over. Venturi meter and Orifice meter over. Next, the third one, the last one is Pitot tube. Okay, so what is meant by Pitot tube? So Pitot tube is a device used for measuring the velocity of flow. So last two instruments or equipments are used to measure the rate of flow. Rate of flow is nothing but discharge. Okay, but Pitot tube is nothing but the instrument for measuring the velocity of flow at any point in a pipe or a channel. Okay, so if the velocity at any point decreases, the pressure at the point increases due to the conservation of kinetic energy into pressure energy. So keep it in your mind. This is very, very important. According to Bernard's theorem also, So this velocity increases means the pressure at the point increases. Okay. In simplest form, the pitot tube consists of a glass tube bent at the right angle. So I will show the picture next in the next slide. Okay, the liquid rises up in the tube due to the conservation of kinetic energy into pressure energy. The velocity is determined by measuring the rise of liquid in the pipe. Okay. Now you can see here in this picture, a simple pitot tube is there. So it is a right angled glass tube attached in the pipe. Okay. So point 2 is just at the inlet of the pitot tube. This is the inlet portion, and point 1 is the far away from the pitot tube. So due to the pressure in the pipe and velocity of the flowing, so this height, that means the head will increases in the pitot tube. So this height, this is the outer diameter of the pipe. This portion is the outer diameter, and this is the h value. Okay. So actual velocity is given by, this is the formula, CV into root 2 G H. CV is the coefficient of pitot tube, coefficient of the pitot tube into root 2 G H. This H is nothing but this H. Okay. So this we already discussed. It is a device used for measuring the velocity of flow at any point in a pipe or a channel. Okay. So it is based on the principle that is the velocity of flow at a point become zero. The pressure there is increased due to the conservation of kinetic energy into pressure energy. So in its simplest form, the pitot tube consists of a glass tube bent at a right angles as shown in the figure. Okay. So this is the derivation. The derivation not quite, but even though we will see the derivation. So here you can see 0.1, 0.2 as I mentioned here. Capital H is nothing but depth of the tube in the liquid. So this is the surface of the water, and this is the depth of the tube, and H is the rise of liquid in the tube above the free surface. So applying Bernoulli's equation at points 1 and 2, we get P1 by rho g plus V1 square by 2g plus Z1 equal to P2 by rho g plus V2 square by 2g plus Z2. This is the Bernoulli's equation I am applying in the section 1 and section 2. So here data lines are same. So both first point and second point lies in the same level. So Z1 equal to Z2. So P1 by rho g pressure 1, P1 by rho g, pressure head at 1 is H, capital H, and P2 by rho g, pressure head at 2 is H plus H, small h plus capital H. Okay, so substituting these values, we get, so P1 by rho g is capital H, because at the head 1, that means at the point 1, the pressure head is capital H only. Okay, while entering into the pitot tube, that means that section 2, the water level increases in the pitot tube. So that is the small h. Okay, so the overall height is the capital H plus small h. So substituting these values, we get P1 by rho g is H, capital H, plus V1 square by 2g. Z1 and Z2 get cancelled because both are same. Okay, which is equal to P2 by rho g is H plus H. Okay. So substituting these values, we get this value, and from this, here capital H is there, here also capital H is there. Both we get cancelled. Okay. So here also Z1 and Z2 as points 1 and 2 are on the same line, and V2 also 0. Okay, V2 also 0. There is no V2 here. Okay, only V1 is there. Okay, because why V2 is 0? Can anybody tell? Because diameter is same. Diameter is same. If as we seen in the continuity equation, if diameter is different, it means the velocity will changes. If larger diameter, velocity is low, smaller diameter, velocity is high. But here diameter is same. So all the portion, the same velocity flow is occurs. So V1, there is no V2 here. So V2 is 0. Okay. So substitute this value h is equal to, finally this capital H on both sides get cancelled. So h is equal to v1 square by 2g. So v1 is equal to root 2g h. This is the theoretical velocity. So actual velocity is given by v1 actual is equal to cv. So I incorporate the quotient of the velocity cv into root 2gh. So as in our previous case, actual discharge, theoretical discharge. Same way here, actual velocity, theoretical velocity. Okay. So this portion, that means the root 2gh is the theoretical velocity. Okay, this is actual velocity. Okay, so actual velocity is equal to cv into theoretical velocity. Okay, so where cv is the quotient of the Pitot tube. Coefficient of the Pitot tube. So velocity at any point is equal to v actually equal to cv into root 2gh. So this is the formula. Okay. So now we will move to the problem. Yes, Pitot static tube placed in the center of a 300 mm pipe line has one orifice pointing upstream and the other perpendicular to it. The mean velocity in the pipe is 0.8 of the central velocity. Okay, here you can see velocity is not given. Okay, the mean velocity, mean means average. Average velocity in the pipe is 0.8 times the central velocity. Okay, what is the central velocity means? If you take a large pipe, the velocity at center more than the velocity in the outer, near the outer of the wall of the pipe. Okay, so for that the average velocity is 0.8 times the central velocity. For that only they given. Find the discharge through the pipe if the pressure difference between the two orifices is 60 mm of water. Take the coefficient of the Pitot tube as cv is equal to 0.98. Okay, so now what are the data given? Diameter of the pipe is given 0.3 meter and h, difference in the pressure head, how much? 60 mm. I converted into meter divided by 1000. So it is 0.06 meter of water and cv is 0.98, coefficient of velocity. Mean velocity v bar is equal to 0.8 times the central velocity. Now the central velocity is given by the equation. Okay, v actually is equal to cv into root 2gh. So substitute in the formula. cv is 0.98 root 2g h is 0.06 meter of water. Okay. So now what is the average velocity? That means mean velocity is 0.8 times the central velocity. Central velocity we already found 1.063. So into 0.8 means 0.8504 meter per second. So discharge Q is equal to, what is the discharge formula? Area into velocity. So area of the pipe. So how to calculate area? Pi by 4 into d square into v bar. V bar is the average velocity. So pi by 4 into diameter is given, it is 0.3 square into average velocity is 0.8504, which is equal to 0.06 meter cube per second. So this is the formula. Okay. So next come to problem. Next problem. Find the velocity of the flow of an oil through the pipe when the difference of mercury level in a differential U-tube manometer is connected to the two tappings of the Pitot tube is 100 mm. Take the coefficient of Pitot tube is 0.98 and the specific gravity of oil is 0.8. Okay, this is also a very simple problem. Here they given difference in the mercury level is given. So in that formula, root 2gh formula, we have to find the initially h. Okay, so h is equal to x into sh. This is sh divided by s0 minus 1. So what is x? Difference in the mercury level 100 mm. So if you convert it into meter means 0.1. So 100 divided by 1000, 0.1. sh is 13.6 and s0 is 0.8. This is not water. This is some oil is flowing. Water means the specific gravity s0 is 1. So oil. So for that the specific gravity is given is 0.8. Okay. So x is 0.1 meter and sh. This is sh 13.6 and S naught 0.8. Okay, substitute all the values. We can get 1.6 meter of water, 1.6 meter of oil, not water, oil. So this is your small h. So next find the velocity of flow. CV into root 2 GH. So CV 0.98 into root into G 9.81 into difference of pressure rate. H is equal to 1.6 meter of oil. So finally we got 5.49 meter per second. So this is the velocity. So in the question they didn't ask discharge. So only they asked velocity. Okay, for that only diameter of the pipe also not given. Okay, so only velocity is enough. It is 5.49 meter per second. That's all. Okay. So next we will move to the next problem. A Pitot static tube is used to measure the velocity of water in a pipe. The stagnation pressure head is 6 meter and static pressure head is 5 meter. Calculate the velocity of flow assuming the portion of tube is 0.98. Okay. So stagnation pressure head. What in the stagnation pressure means? Pressure at static condition. Okay, is 6 meter. Static. Next, static pressure head. Okay, that means static means at rest. Stagnation means when not flowing. Okay, so it is 6 meter. Stagnation is 6 meter and static pressure head is 5 meter. Okay, so now what is the difference in the pressure head? It is 6 minus 5. So here they directly given that P1 by rho g and P2 by rho g value. Pressure head. Please note down pressure head. Pressure head is nothing but what is the formula? P1 by rho g, P2 by rho g. They directly given in the question. Okay, so it is 6 minus 5. It is 1 meter. So this is your h value. So substitute in this formula. V is equal to, that means V actual velocity is equal to CB into root 2 GH. It is 0.98 into root 2 into 9.81 into 1, which is equal to 4.34 meter per second. Okay, this is the easy formula. Once you understand the question, it is very easy. If the pressure head is given means you directly substitute. Okay, pressure given means first you have to find the pressure head. That means P1 by rho g and P2 by rho g. After that only you have to substitute in this equation. So next problem, this is very, very important problem, frequently asked problem from the Pitot tube. Okay, so I read the question. A submarine moves. You know about submarine. Okay, submarine moves in the sea. Okay, a submarine moves horizontally in sea and has its axis 15 meter below the surface of water. Okay, so a submarine moves in the water. Suppose if you consider this is the sea level. This is the sea level. So this is the submarine. Okay, this is the submarine moves in the water along this direction. Okay, so the submarines moves at the depth. How much depth? 15 meter. Okay, 15 meter. Okay, below the surface of water. A Pitot tube is properly placed just in front of the submarine and along its axis is connected to the two limbs of a U-tube containing mercury. The difference of mercury level. So here you can see difference of mercury level is given. It is 170 mm. Find the speed of submarine knowing that the specific gravity of mercury is 13.6 and that of seawater is 1.026 with respect to fresh water. Okay. So here x value is given, it is 170 mm, which is equal to 0.17 meter, and the specific gravity of mercury is SH. It is 13.6 and S naught is 1.026. Okay. So due to this differential pressure head is given. That means not pressure head. Difference in the mercury level is given in the problem. So we have to use this formula. Okay. So H is equal to X into SH divided by S naught minus 1. So which is equal to X equal to 0.17, SH 13.6 divided by 1.026 minus 1, which is equal to 2.0834 meter. So B is equal to root 2 G H. So root of 2 into 9.81 into 2.0834. So substitute this H value in this equation. Okay. So it gives 6.393 meter per second. So the submarine moves under a velocity of 6.393 meter per second. Okay. So mainly submarines are velocity we will give in terms of kilometer per hour. Okay. So we have to substitute meter per second into kilometer per hour. So for that we have to multiply by 60 into 60 divided by 1000. So what is this 1000 means? We converted meter into kilometer. Okay. So 1000 meter which is equal to 1 kilometer. So for that purpose we divide the that meter into kilometer. So divide the 1000. Next per second into hour means we have to multiply by 60 into 60. So finally we got kilometer per hour. Okay, so it is 6.393 meter per second. If you converted kilometer per hour means it is 23.01 kilometer per hour. So this problem is very important problem in the Pitot tube. Please be remembered. Okay, so in this problem they given difference in the mercury level. So substitute this H formula. H is equal to x into SH divided by S naught minus 1. Then after finding the velocity, that means actual velocity converted into kilometer per hour. That means 60 into 60 divided by 7. What are the answer you got? You have to multiply by 60 into 60 divided by 1000. Okay, so this is the problems in the Pitot tube. Okay, students. So we seen in this class, previous class and in this class, Venturi meter, Orifice meter, Pitot tube. 3 important chapter. So next video is flow of liquid in pipe bend. That also very simple. One problem is there that we will discuss in the next video. Okay.